This is a geometry problem. So in the figure, a kite with two right angles is circumscribed by a circle. The circle is then circumscribed by a square such that the diagonals of the kite are parallel to the sides of the square as shown. The longer sides of the kite each have length x meters. The sides of the kite divide the square into three regions shaded dark gray, white, and light gray as shown, where each region is of area 2 square meters. If x squared equals a plus square root of b, what is the value of a plus b? And so for this one, we first notice that we have to define more variables. We're not done defining variables yet. So we have to label these pairs of sides over here, because these aren't set yet. And then that means that the side length, this thing down the middle, the side length of the square is actually x squared plus y squared, square root of x squared plus y squared by the Pythagorean theorem. But we also know the area of the square. The area of the square is 6. So the area of the square is both equal to 6, and it's also equal to the side length squared, which is x squared plus y squared. So we have our first equation. But we have two variables, so we need to find a second equation. And where else can we find that? Well, let's look back at the information. We have that each of the regions is 2. And so the fact that the dark gray equals the light gray, that just works by symmetry. But we also need to have that the area of the white inside is 2 in order to be able to uniquely determine this square and the areas of the individual sectors. So that means that the area of the right region is 2 is important. So the area of the white region is xy, because you can like move them about to get a x by y rectangle. And so xy equals 2. So now we have two equations and two variables. And how do we solve this? Well, the nicest way to do these kinds of things, normally when you have x squared plus y squared, is to adjust that and use that to get x plus y. So we can add the first equation with 2 times the second equation to get that x plus y squared equals x squared plus 2xy plus y squared equals 10. And then we also have the x minus y squared equals x squared minus 2xy plus y squared, which equals 2. That means that x plus y equals square root of 10, and absolute value of x minus y equals square root of 2. And now we just check some signs. Well, we clearly have that x is greater than y here. So that means that x minus y is positive, and similarly, x plus y should be positive. So that means that we have that x equals x plus y plus x minus y over 2, which equals root 10 plus root 2 over 2. And then after that, we extract x squared, which equals 10 plus 2 root 10 root 2 plus 2, which equals 12 plus 4 root 10 over 4, which equals 3 plus root 10, which gives you an answer of 13. So that's question 28. It's nice. The important thing is that you have to label another set of variables. I guess this would be doable if you let like s equal the length of the side length. Okay.